In fact, in each of your brains, there's some 10 to the 15th synaptic connections. So that is way more than the number of stars in our galaxy, albeit not as many as the grains of sand in the Sahara Desert. But it gives you some sense of the scale and the number of connections that are driving each of your behaviors. But the synapse is not like a grain of sand, which sits there inertly. The synapse is a small, compact means of communication. And in order to try and indicate how information transfer flows across synapses, I thought it might be useful to see these electrical impulses moving between neurons and circuits across synapses in something resembling, it's not real time, but it's a slowed down view, but nevertheless it gives you some indication. So if we could have the first animation, we're going to be looking at these electrical impulses, these flashes, which are called action potentials, are crossing 3 neurons in a circuit here. And as we look in higher power, you can see it crosses the synapse, moves on to the next neuron in the circuit, crosses another synapse, finally activates the next neuron in this chain. And if we begin to focus at slower speeds and at higher magnification, we're going to focus on the information transfer at that single synapse. And so there is the dendrite on the right, the synaptic terminal on the left, and as the impulse information comes down, these little green disks are channels in the synaptic terminal that open. They let calcium ions into the nerve terminal. Calcium ions then activate small packets of neurotransmitter, which release their contents into the gap at this synapse. Some of them diffuse away, but others activate receptors on target neurons. They open yet further channels, which let sodium ions in, and so this information transfer propagates from one neuron to the next along these connections. So in order to understand how behavior depends on circuits, depends on information transfer in synapses, we need to approach these problems from a developmental